All right, welcome to Chemistry Unit 11, Vodcast A, Stoichiometry, Coach Forster.
Stoichiometry.
Your favorite thing.
My favorite word in all of chemistry.
Here comes a what is that? That's a mole?
That's a mole. There's a mole doing some sort of science experiment.
He's got a pretty cool lab coat on.
I know, it's like the Technicolor mole there.
So we're gonna look at moles.
Mm-hmm.
Not really that kind of mole.
No.
But
not any moles that will be on my face or anything like that.
No,
but
it's a good laugh every now and then to get put an actual mole in there. So what is a
Mm-hmm.
mole, Coach Forster?
A mole is a unit of quantity. It's counting something. Like if you have like a dozen donuts or a dozen cookies or whatever. It's a unit of measurement of a quantity in chemistry. And it's denoted by what we call Avogadro's number, which is a very important person in chemistry that you're going to learn about when you do a project in here. And we call the Avogadro's number. It's a very constant number, and we'll figure out what that is a little later, probably in this PowerPoint. This is Avogadro's number. It is 6.02 times 10 to the 23rd, and it could be a number of anything. Okay, items. It could be atoms. It could be molecules. It could be.
But again, just like you can have a dozen anything.
Right.
You can have 6.02 times 10 to the 23rd.
Anything.
Mm-hmm. It's a way to show how many are there.
Right.
It's not necessarily a unit of itself.
Right.
Okay. It is a way to show how many things or items
you have there.
We're working with.
And it's equal to 1 mole. And a mole is just a unit of measurement in chemistry. Don't get caught up in what the word means and all that. Right. So it's just a unit of measurement.
Okay.
It's a very, very large amount. So that is 6.02 followed by 21 zeros after that.
Or if you wrote that out, 6.0. I don't know even how to say that with
I've heard it one time, but it's six like quadrillion, million, something like that. So it's a very, very large number.
A bunch of zeros.
It's a bunch of zeros after it.
Okay. So how large really is this? And so we just took a mole of hockey pucks, Coach Forster.
Mm-hmm.
We could have, if we had 6.02 times 10 to the 23rd hockey pucks, that thing, that mass of hockey pucks would equal the mass of the moon.
That is
quite a large number of. A mole is really large. A mole of basketballs would fill a bag the size of the Earth. If we had the Earth, we could put 6.02 times 10 to the 23rd just in the surface. Not the surface area, but in the total area, the volume of the Earth.
Wow.
A mole of pennies would cover the entire Earth a quarter-mile deep.
Wow.
That's a 400-meter dash.
That is.
That's a lap around the track.
Lap around the track. That
straight
deep
up and down.
of pennies. And they would still be worthless if you had that many pennies.
Yep.
So even if you don't comprehend the number of mole, hopefully some of these analogies kind of helps you.
It's a very large amount. So you guys are going to do a project where you're going to look at make a mole poster, and so that's how you're going to spend probably the first 3 days or so of your unit is kind of researching that and working on that. Trying to figure out kind of some of these things relate to each other.
Right.
Now, the next concept we need to look at, Coach Forster, you want to take us through molar mass?
Molar mass, okay. So a molar mass is how we relate the mole concept to elements on the periodic table. So the mass of 1 mole of an element, okay, we were talking about moles of basketballs and hockey pucks, but now we're talking about elements on the periodic table. So a mass of 1 mole on the periodic table is equal to a number on the periodic table.
Okay.
And the atomic mass tells you how many units or how many moles per atom there are. Okay, so it's the atomic mass per atom.
Okay, and so on our periodic table, on the ones hanging in our room, it's the little red numbers down underneath.
The red number.
If you're on the periodic table, if you're on the one that we use on tests and stuff, it's going to be the number right underneath the element.
Right. It's usually going to be the larger number.
It's going to be the larger number of the two, right?
Or it's the decimal number as well.
So that is the mass of 1 mole of that element.
Element. Yes. And its units. So this is a good thing for you to remember. The units for molar mass are grams per 1 mole. So it's the amount of grams in 1 mole. So grams over 1 mole of an atom. Why do I keep saying atom? Element of an element. Grams per 1 mole of an element. And usually we round that to 2 decimal places.
2 decimals there, and you'll see that throughout the periodic table as you look at these. 2 decimals. So let's look at a couple examples. If you were to look these up on your table, and you can grab yours and look at them with us just to make sure you know you're looking in the right spot. But carbon has a molar mass of
12.01.
12.01 grams per mole.
But you'll notice that it has a atomic number of 6. Okay, so we're using the larger one of the two numbers there. We're using the 12.01
using the mass number.
grams per mole.
The decimal number. Okay.
Right.
Most of them will be a decimal.
Aluminium. Aluminium, as the Brits say.
26.98.
26.98 grams per mole.
Grams per mole, again, just finding that on the table. Zinc, if you'll look up zinc, make sure you're looking in the right spot again.
Coach Arthur, I zinc, that is 65.39.
Zinc it is.
I zinc.
You zinc correctly.
Too many chemistry jokes in one slide of lecture here.
Okay, let's
let's reel it back in.
Let's move on. Okay,
let's move on.
So those are some examples. Just make sure you're looking in the right place. Now, Coach Forster, the last thing we're going to do, let's look at how would we figure the molar mass of, say, water.
Well, Coach Arthur, we would have to know the formula for water.
Well, I believe it's H2O.
It is H2O. Coach Arthur, do you know what H2O is? You know what H2O4 is?
I've heard this joke before.
Oh, really?
H2O is to drink.
What is H2O4?
It is to drink.
That's right. It is to drink.
So,
but anyway, let's try to calculate the molar mass.
So what do you need first here, Coach Forster?
Well, you need to see how many elements you have. Okay. So here you've got two hydrogens. And you've got 1 oxygen.
1 oxygen, okay.
So you're going to add up the molar mass of hydrogen twice.
Okay.
So it'll be
1.01.
Plus 1.01.
Okay. And oxygen
plus
is 16.0.
16.0.
0.00 if we're looking at 2 decimals.
If we're looking at 2 decimals. And Coach Arthur, my math skills are a little bit shaky right now.
18.02
grams
per mole.
Per mole.
So there we've calculated the molar mass of a compound. Okay, just by adding up the molar masses of each of the elements in that compound. Okay, let's try sodium chloride here.
Well, we need to write the formula for this, so I need some help on the charges.
Well, Na is +1, Coach Forster.
Okay, +1.
And chlorine is -1.
Okay. So we got a situation here where the charges both cancel out, and you get NaCl.
Right. Okay.
So how many of each do we have here?
We have 1 sodium.
1 of those.
We have 1 chlorine.
And 1 of those. Okay, so let's just add them together.
Sodium's 22.99. Chlorine is 35.45. Coach Forster, that's going to be 58.44.
What would I do without you?
I don't know.
I couldn't have.
I'm just glad it wasn't 3 numbers because I had to pull my calculator.
I know. So pretty simple there. 58.44. You just add those 2 numbers together, and just add them. If you got more than one, add them more than once, and that tells you the molar mass.
Okay, I think that's it. Well, I think they're going to give us the answers here, but we'd rather have your writing, Coach Forster.
Well, yeah, I know.
But you can see what we did there. Let's do. Let's just do sodium bicarbonate. You guys can look at the sucrose. We may give you the formula here.
Yes.
Let's look at sodium bicarbonate. A little more difficult example. Sodium, Coach Forster, is Na. It's +1.
And then I think
bicarbonate. Let me look here. -1. It's HCO3. Yeah, HCO3 is -1.
Okay, so we got NaHCO3. All right, here. Now notice here we got more than 2 elements. Now we got 4. 4 actually. 1, 2, 3, 4. Okay, so we got sodium. What's its?
Sodium is 22.99. Plus, what's next? Hydrogen. 1.01.
Plus.
Next is carbon, which is 12.01.
Plus.
And then we have 3 oxygens, which oxygen is 16, so 16 times 3 is 48. Okay, and if we add all those up, 84.01 grams per mole. Okay, so again, we're just adding up. Pretty easy to find there. All you got to do is add, but you have to know where to look on the table and all those kind of things.
Right.
You want to give them the formula for sucrose?
Yeah, I think sucrose, I believe it's C6H12O6. So you guys can use that formula to help figure out.
See if you guys can figure molar mass.
See if you can figure out molar mass.
Yeah, and I think that's all we've got here. We're not going to go put all that up, but that is it for this one. We will see you next time.
All right, we'll see you later.